Today our topic is similar right triangles. So how can I use similar right triangles to solve problems? Key terms: altitude of a triangle. We talked about this in chapter 5, but a refresher: a perpendicular segment from a vertex to the opposite side, or a line that contains the opposite side. So we need this because it's important for what we're learning today. Theorem 7.5. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if you look, there's a nice drawing here. So we have the altitude here is drawn. So it makes three similar triangles. We have triangle 1, we're going to call this little small triangle right here. Triangle 2 is this triangle right here. And then triangle 3 is just your original triangle, triangle ABC. They're right triangles and they are similar. So using this theorem in example 1, identify the similar triangles, then find the value of x. So here we have our little triangle, triangle 1. Here we have our medium triangle, triangle 2. And then we have our big triangle. So I'm going to redraw the big triangle first, triangle EGF. And make sure I label the side lengths 3, 4, and 5. Then I'll draw the medium triangle, but we have to make sure we orient it correctly. We have the short leg would be GH, so I'm going to put G here, H here, and then F. So G, H, F. So we have X. 4 is the hypotenuse, and we don't know the last leg. And then triangle 1, the little triangle in blue. Again, we have to make sure we orient it properly, so it's going to be E, H, G. With our right angle there. We know the hypotenuse is 3. The long leg is X, and we don't know the shorter leg. Similar triangles mean proportional sides. So to solve for X, all we have to do is set up a proportion. I'm going to use the big triangle and the green triangle, the medium one. 3 and X are corresponding sides, equals 5 and 4 are corresponding sides. So we can set up that proportion. Cross multiply. 5x equals 12, divide both sides by 5, we get x equals 12 over 5, or if we want to make that a decimal, 2.4. Just a little right triangle humor for you. Geometric mean. This is the big piece. We learned about the geometric mean in the beginning of chapter 6, and the geometric mean of two positive numbers a and b is the positive number x. So remember, x was in both the proportions, so x squared equals a times b, and then x was the square root of a times b. So the geometric mean can be found in that special triangle where the altitude is drawn. So reading through this, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Segment 1, segment 2. The length of the altitude, the red segment, is the geometric mean. So when it's the geometric mean, that means it's the x of the lengths of the two segments. So the lengths of the two segments would be your A and B. So if you see, they set up that proportion. CD is both. It's your x. And then the length of one leg, AD, right there, and the length of the other leg that it cuts in half, DB or BD. This is the geometric mean altitude theorem. So that's one way to set up a proportion, depending on the information you're given. The second theorem is the geometric mean leg theorem. This theorem, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. Again, we're working with that 2 segments. However, this time you're not given the length of the altitude. The length of each leg of the right triangle. So each leg. So AC would be a leg, and CB would be a leg. So each leg of the right triangle is the geometric mean. So that means you're going to see those legs twice. CB, CB. It's like your X piece. Or if you're given the length of AC, you would have AC and AC. But what are they the geometric mean to? The lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So the length of the hypotenuse is this whole thing, AB. And you see that right here. Then, as we know, the hypotenuse is split into 2 segments, AD and DB. So when we're given CB, the segment adjacent is DB. And when we're given AC, the length adjacent, the side adjacent would be AD. So these can be kind of confusing to set up until we get used to it. And I understand. So don't feel like you have to get it right away. It just takes a little while to adjust, okay? So let's just try some practice problems. I've copied over the theorems, so we have this reference. Remember, we have the altitude theorem and the leg theorem. So let's look at our first example. Solve for y. Identify the theorem being used. First off, we look. Are we given the length of the altitude? No, we're not. So we can't use the altitude theorem. We have to use the leg theorem. So then, the leg theorem, we have to figure out which leg we're given. The leg of the big triangle. We look at the big triangle. So these 2 are our legs. Well, we know y. So we set up y as our geometric mean. So it goes on the bottom of the first ratio, the top of the second ratio. Then we know it's the geometric mean to the length of the whole entire hypotenuse, which is 9, and to the length that it is adjacent to. So in the split section, it's adjacent to this 3 piece. So really in this example, it was just knowing which piece is the geometric mean, and that's our variable y. Solve by cross multiplying. Y squared equals 27. Undo the y squared by taking the square root of both sides. So y equals the square root of 27. If we want to simplify that square root, we could take out a 3, and it'd be a 3 square root 3. Or we could just round it, approximate it to about 5.2. Any of those answers would be acceptable. The second example. First we check, are we given the altitude? Yes, we are. So we're using the altitude theorem, which I think is the easier one. The altitude is the geometric mean, so that goes on the bottom of the first ratio and the top of the second ratio. Then it's the geometric mean of the 2 pieces of the hypotenuse, so 12 and y. Cross multiply in order to get your answer. 12 times y is 12y. 18 times 18 is 324. Divide by 12 on both sides, and y equals 27. All right, that's all the notes that I have for you today. Don't forget to do your notes quiz to practice what you learned in the video. Thank you for watching my video, and please subscribe to my YouTube channel.